A sequence is given by the recurrence relation u1 is equal to 4, and then u to the n plus 1 is 2 times u to the n minus 3 for n greater or equal to 1. Prove that the general formula for this sequence is un is equal to 2n minus 1 plus 3. So basically what happens here, if you take 4 as the first term, okay, it will work out 2 times 4, which is 8 minus 3, which is 5. So the next term in the sequence will be 5. And then what you do, you substitute that in to get the next term. And what we're working out here is what is going to be the sort of general formula for the sequence. Is this true? Again, it's proved by induction, so you do actually need to know the result before you can actually prove it. So we've got u1 is 4, u to the n plus 1 is equal to 2u to the n minus 3 for n greater or equal to 1. So we've got to prove that un is equal to 2 to the n minus 1 plus 3. Okay, so first step is we need to prove it true for a particular value. So in this case, it's going to be n is equal to 1. So if u1 is going to be 2 to the 1 minus 1, so we're using this formula here, plus 3. 2 to the 1 minus 1 is 2 to the 0 plus 3. 2 to the 0 is 1. 1 plus 3 is 4, and we knew already that u1 is 4. So therefore, true for n is equal to 1. Now we've got to assume true for n is equal to k, i.e. that u to the k is equal to 2 to the k minus 1 plus 3. And now using that, we've got to prove true for n is equal to k plus 1. So we go back to this one, and u to the k plus 1 will be 2 times u to the k minus 3, which will be 2 times my u to the k, which is 2 to the k minus 1 plus 3. This is my assumption, minus 3. If we continue to work that out, if we combine that 2 with that, we get 2 to the k minus 1 plus 1. So you need to be quite good at indices for this. Plus 6 minus 3. This gives me 2 to the k plus 3. Now, if we've got k plus 1, this will become k plus 1 minus 1, which was 2 to the k plus 3. So we've actually got what the k plus 1 formula. So we've actually proved it. And then we need to have our conclusion. The result is true for n is equal to 1. And then if it is true for n is equal to k, then it's also equal to n is equal to k plus 1. Therefore, the result is true for all n greater than z by the principle, all positive integers by the principle of mathematical induction. Okay, so this has been a video to show you how to prove a general formula of a sequence using mathematical induction. I hope you've understood, and I thank you very much for watching.